Okay, well, hello, everybody that's not here, whatever country you're in, watching this. So anyway, we're gonna look at related rates in section 210 here. And so this is word problems. Huh? What's going on? Anyway, everybody says hi and hope you're enjoying whatever beach you might be on at Swan Lake. So anyway, illustration 1 says we've got a ladder 25 foot long and it's leaning against the wall. I don't care which way you draw the wall, but let's just do it this way. So here's the ladder. It's got steps on the ladder. And then what's going on? It's 25 foot long, so the length is 25 feet. We can use 1 tick mark for feet, 2 for inches. It's leaning against a vertical wall. The bottom of the ladder is pulled horizontally away from the wall at 3 feet per second. So we're pulling away from the wall at 3 feet per second until it falls down, okay? So what kind of change is this? Like what axis do you want this one to be? The horizontal axis. What letter? X? That'd be good to have that be the x-axis. What about the vertical one? That'd be the y-axis. So anyway, so I'm over x, up y when it's leaning there. I don't know. Like if this is the origin, so we might put the origin here at the base of the wall. And it says it's a vertical wall, so it's a 90-degree angle, right? So what, so this ordered pair right here would be what? At the base of the ladder. What would that ordered pair be? If this is the origin, how far over am I? About x. Over x, up 0. What about this one? Over 0, up y. Does that make sense? Okay, so the length horizontally is x feet, and the length vertically is y feet. So if you want to put a tick mark on there for feet, we can. And then we've got, what would L be? Instead of L, what letter could we maybe use for that one? Z. You could use Z if you want for this one, but Z is 25 feet. Is that ever going to change? As the ladder slides, that's always going to be 25 feet, right? So what is changing is the Y is going to get lower, right? Because the ladder is going to go down the wall, and then the ladder is going to go out the sidewalk until it's far enough it just falls, right? So anyway, that's kind of the deal on that. So this 3 feet per second, what does that represent? If I had to label that with a variable, what would it be? Or with letters? Is it a rate of change? Yeah. And what's a rate of change represented with? What represents a rate of change? A rate of change. What is calculus? What's calculus? The science that measures rates of change. And what are we doing in this chapter? That measures instantaneous rates of change, derivatives. Isn't this a rate of change? It's change in your distance, your x distance with respect to time, right? So what would I label this as? Anyway. You had to do it in 54. dx dt, right? Wouldn't that be dx dt? The change in your x distance with respect to time. So after 1 second, it's going to be 3 feet further to the right. After 2 seconds, it's going to be 6 feet further to the right. Does that make sense? So it's dx dt. All right. So we got to figure out what the question's answering. Okay. So t is a measure of time. And anyway, so the bottom of the ladder is pulled horizontally. Suppose we wish to determine how fast the top of the ladder is sliding down the wall when the bottom is 15 feet from the wall. So we're trying to look at the moment of time, and I'm going to use a different color here. What contrast with that? Red. So this is going to slide down the wall, and I'm going to look for the point in time where, now this is still going to be 25 feet, right? But I want to know how fast it's sliding down the wall when this is 15 feet away. So I believe that's what it's asking us to do. When the bottom is 15 feet from the wall. So I got 15 feet there. Now that's 25 feet. Could I figure out what this is right here? So what this height here is, could I figure that out? How? Pythagorean theorem. So what is it without using a calculator? If this is 15 and that's 25, what kind of relationship do we have in right triangles? 3, 4, 5. So this would be 20 feet, right? Good. So that's 20 feet, so we can figure that out. This one's 15, that was given. This is 25 feet, that's given. And at this point in time, the height would be 20 feet. But what are we looking for? What's the question? It says, how fast is it sliding down the wall? So that's this arrow, right? And what do we represent that arrow with? If this arrow to the right was dx dt, what's this arrow going down? dy dt. So this is dy dt. All right. So anyway, we're trying to find dy dt at the moment in time when that's 15 feet down the wall. Now in general, what do we have? We have x, y, and z, right? Or x, y, and L. And what do you know? In general, what equation do we have from Pythagoras? X squared plus y squared equals, in this, z squared, or in this case, we've got L squared. Morning, Emily. You're on candid camera. Emily says hi. Anyway, so we got this. So what can I do with this? We have dx dt, right? We don't really have dy dt, and I don't know if we need dz dt. But anyway, so what do we have here? Let's just actually put in what we have. So L squared is 25 squared, right? 25 squared is 625, right? If you got 25 quarters, you got $6.25, right? And then what can I do with that equation for the red? I can take the derivative of that with respect to what on both sides? What letter? T, right? So take the derivative of that with respect to t. So this is similar to what we did last time, right? So anyway, if I do that, what do I get? Don't I act like it's okay? So if you have a variable other than t, act like it's okay. So what's the derivative of x squared if you act like that's okay? 2x, and what do I got to attach? By the chain rule or implicit differentiation. dx dt, right? So if I'm taking the derivative of t, or with respect to t, that's the one that's on the bottom, and the variable will be the one on top. So I'm attaching that by the chain rule. Plus, and then I've got act like this is okay, 2y, derivative of y squared is 2y, but that's a y, not a t, so what do I attach? dy dt. And then on the right, that equals the derivative of the right side. What is the derivative of the right side? 0. The derivative of any constant with respect to any variable is always 0, right? Because the graph would be a horizontal line, just slope is 0. But anyway, so we get this. Now, the question is, we're looking at the point in time of the red. So when x is 15 feet to the right, y is 20 feet up. So we know those two, right? So this is going to be 2 times x is 15 times dx dt. Do I know dx dt? 3 feet per second, right? So times 3, and then plus 2 times y. We figured y out to be 20 because we used Pythagorean's theorem. 3, 4, 5 right triangle relationship. And then times dy dt, which is what we're trying to find, and that equals 0, right? Does everybody agree? So we're trying to find dy dt. How fast is this thing going down, sliding down the wall? Rate of change of y with respect to time. So if I do this, go ahead and multiply that. 30 times 3 is 90. So anyway, we've got 40 dy dt equals minus 90, because this is 90 and I got it to the other side, right? Get all your dy dt's to one side, everything else to the other, and then divide both sides by 40. And this minus 90 over 40 is dy dt. Just solving that equation for dy dt, right? Everybody agree? And what's the limit? Of course, that simplifies. So if I say dy dt equals minus 9/4 then, right? Well, what does that really mean? What is the label for this? What's dy's label? Y is the distance, right? What distance? Feet? You just have a long weekend, didn't you? All right, zone back in. It's feet per second. But it's negative. All right, so I know we had number 54 from the previous section on the board earlier, and I said give a physical interpretation. Right? What did that mean? Well, what's this minus sign mean? Is that up or down? Or left or right? It's down because it's a y, right? It's a change in a y is negative. So that means the ladder is doing what? Sliding down the wall at a rate of 9/4 of a foot per second, which is 2 1/4 feet per second. So we could just say that. So the ladder is sliding down the wall at a rate of, now do I put the minus down here? Do I put the minus here, or do I just say 9/4? Just say 9/4 because I said down the wall, which is in the negative direction. So that's what that minus sign says. At a rate of 9/4 of a foot per second. Like I said, I don't really care if you make that 2 1/4, no real, or 2.25, it doesn't matter, but 9/4 is just as easy. So the ladder's falling at a rate of 9/4 of a foot per second. Does that make sense? Biggest thing is try and come up with equations, and then if you have to take the derivative with respect to a different variable, we're using the chain rule. That's what implicit differentiation is all about, right? So this one is actually a fairly decent one. As far as practice odds in section 210, some good ones are numbers 1 through 13 and numbers 21 and 35. Okay, so we're gonna practice some of these, and then you've only got to do and 39. Okay, so I'm gonna do 1 or 2 of these or 3 of these depending on what we have time today, and then this is not that many odds. This is only 7, 8, 9, 10 practice ones, and I'm gonna do 2 or 3, so that leaves you, 7-ish that you can do for practice to make sure you're good at word problems. Oh, and then what's our little, where is this again? Where's this? Reality, baby. That's where I live. You come up, don't bring me down. But what do we do with word problem? Life's a word problem. Work it out. All right. So anyway, so let's look at a couple of these. I'm gonna break this off right now so that we can work on them in class a little bit, and then I'll throw some on the board. It might still be recording.